Hey guys, happy Thursday. Today we are building on our work on Tuesday about physical and chemical changes. So today I want us to kind of remember one of those examples and think about, for number one, for our do now, what type of change is it? Is it chemical or physical? When you fry an egg, how do you know? How did you decide what you chose? And what about when you crack an egg? Is it a physical or chemical change? I'll say this, one is physical, one is chemical. Remember that a physical change is when the molecules stay the same, and a chemical change is when the atoms rearrange to form new molecules, just like we've been learning about. Let's keep going. Go ahead and pause me if you want, and then you can answer those questions. After we talk about our scientists of the day and our learning target, we have some vocab too. I should probably put that in the agenda. We're going to do some breakout rooms where you guys are going to sort some changes, are they physical or chemical? And then you're going to, and I'll do this one with you, there's an example, there's a reaction that you're going to watch a video of. You're going to talk about its properties, and that's what you're going to write about. And then tomorrow on Friday, we're going to put these together and write a whole ACE, which is like a science version of races, but we don't need the R and the S, so we just do the ACE. And then you're going to do more of those for your independent work, and the last one is your exit ticket. This is Eugene H. Trinh. You might be thinking about how old he is, but he's a Vietnamese American biochemist. Bio meaning life, and chemistry meaning study of matter. So he actually studies the matter that makes up life, the different molecules, etc. He was the first Vietnamese American astronaut in space, and he flew on the space shuttle in 1992. He did some experiments up there. When he was born in Saigon in southern Vietnam, and he moved to France, and then he moved to the U.S., and he worked at NASA. He started working at NASA 1979. That's before I was born. He still works there now. He's like one of the lead directors, something called the Physical Science Research Division in the Biological and Physical Research Enterprise. I don't know what that means, but that's his title. This is him. You can notice the clothes. I do remember those types of clothes because I was a kid in the 90s. That's the kind of stuff I wore. Look at those jeans he's wearing. I love it. I do want to share this with you. It's a little bit outdated now because this is until 2017, about 3 years old. But currently NASA is training new astronauts, and they're building new rockets and new space systems to try to get people back on the moon and eventually to Mars. And this is just an example of why that's going to be kind of a problem. Now, if you look down in the 1950s and 60s when we first built our space program, we were spending 4.4% of all of our money on NASA. And right now it's down to less than 0.5%, at least in 2017 it was. And so as we're trying to build up things again and not just send people to space in like near or close orbit, which is where the space station is, but all the way to the moon, which is a lot further away, and you need very different systems to do that. They don't necessarily have the budget to do that. So everyone's trying to figure out how to make that work on smaller amounts of money. So you can kind of see that in the late 60s, after we landed on the moon in 1969, you can fact check me on that. But after that, we were like, well, we did it. We can cut the budget because we were spending a lot of money on space at that time without anybody really knowing why we were doing it. Okay, so today I will use properties of matter. We'll talk more about what that means as evidence to support a claim about if a change was physical or chemical. So we're still talking about is a change, physical change or chemical change, and we're using properties of matter as evidence to support that claim. Remember that a chemical change, I said this a minute ago, a chemical change is any change that makes a new substance with different molecules. And a physical change changes something about the substance, but actually doesn't change the molecules of the substance. Fix this, okay. And that's what was our main thing on Tuesday. If you forgot about this or you missed Tuesday, you might want to go back and do Tuesday's lesson as well, because it's kind of the introductory to this. Okay, so remember that during a chemical reaction, the stuff that we don't see is that molecules break apart. Here are these molecules in the reactants. These molecules, the atoms break apart. They rearrange and they form new molecules in the products. And when this happens, we should see different properties like oxygen and methane, these molecules over here, they don't act the same as carbon dioxide and water. They water is a liquid at room temperature. These are both gases. Things like that. So you should be able to be like, oh, there is new stuff over here because it acts different. It has very different properties. And then we know the chemical reaction happened. We know that molecules broke apart and produced new ones. Okay, so real quick, I'm going to introduce you to 3 different types of properties of matter. A property is a trait of or a characteristic of matter. Some of we talked about before were odor, taste, shape, texture, color, flammability, solubility. There should be a comma here. Boiling point and density. And so 3 of them that I think we don't, and there's technically 4 that we maybe need a little practice with are density, melting, and boiling point, which are similar but different things, and solubility. So let's talk about what those mean. So density. Density is how compact something is. You can multiply, or you can divide its mass by its volume if you want to do it mathematically. But it just means, like here, things are more dense here. Solids are more dense because the molecules are closer together. You know this. Gases, because the molecules are so far apart, we can say they're less dense. But even different solids, some things can be more dense. If it's small and it's heavy, it's dense. If it's big and it's light, like a pillow, you're like, oh, this is not dense at all. Things that are denser than water will float. Sorry, I flipped that around. Rocks are denser than water and they sink. Corks, even though cork is a solid, it's actually less dense than water. It's got a bunch of holes in it, so there's like full of air, and so it floats in water. Things less dense float in water. Things denser than water sink, and that's true in air. Things that are less dense than air will float, like helium balloons. Helium is less dense than this mixture of gases that we call air, so it actually floats. Just one more thing to think about for density. Okay, melting point and boiling point. The point means temperature. Melting temperature, boiling temperature. A melting point is the temperature when a solid melts. Think about chocolate. It is solid at room temperature. You heat it up a little bit, it starts to melt. Ice will melt at 0 degrees. You take ice out of the freezer and it immediately starts to melt. But gold is a metal, and you actually have to heat up to over 1,000 degrees Celsius to get it to melt, but you can. This is a picture of melted gold. That's how you melt it and you make it into jewelry and stuff. Boiling point is something similar, but it's the temperature. The point, remember, point is temperature at which a liquid will evaporate, will boil. And so carbon dioxide, CO2, boils at very cold temperatures. So even though it's really cold, it'll still boil, it'll still be a gas. Water begins to boil about 100 degrees Celsius, pretty hot, 212 degrees Fahrenheit. But gold, you can actually boil gold. You can turn it into a gas, but you got to heat it up really hot, 2,700 degrees Celsius. That's like in a star or something, that doesn't happen on Earth very often. And the last one is solubility. Solubility is its ability to dissolve, which means to break into small pieces. So this is a picture of like a candy or a pill dissolving. It's breaking into little small pieces. Here, this is like a piece of something and it's breaking up and mixing into the water. So when you separate and you mix into a solution, usually water, but it doesn't have to be water, that is its solubility. And we didn't do this test, but sometimes we do, you can get a lot of sugar to dissolve in water and a lot less salt. So sugar, we say, is more soluble than salt. Or you can just say, like, if I put my phone in water, it will not dissolve. It will just sit there forever. It is plastic. Plastic is not soluble in water, while sugar cubes are. Okay, so for our breakout rooms, the first thing you guys are going to do is put cooking, freezing, dissolving, rotting, burning, breaking, rusting, and I think the last one there is digesting. Are those chemical or physical changes? You're just going to figure out which ones they go on and type them up. Then you're going to watch this video. And you're going to decide if this is a chemical or physical change. And all this video is somebody burning a marshmallow with a torch, which is pretty cool. So let's do this real fast. So this is burning a marshmallow, uno. This is a chemical change. Think about how you know this. Okay, so what are the properties that change when you burn a marshmallow? Does the color change? Heck yeah. I know this because Before it burns, the marshmallow is white, soft, and sweet. It tastes sweet. After after you burn a marshmallow, or after the reaction, something like that, it is white anymore? No, it is black now. The color changed, the property changed. Is it still soft? Nope. It's like crunchy, or it's crispy. How about that? The burnt part is crispy. The inside is not burnt; it's only melted, but the outside is burnt. So after you burn the marshmallow, it's black, crispy, and it's bitter. Burnt things taste bitter. If you eat I actually kind of like them burnt because then I eat the whole thing and I get the soft gooey and the crispy on the outside, and that's yummy. But if you burn the entire thing, the whole thing would be black, crispy, and bitter. This is my evidence that it's a chemical change because it changed the properties. It changed the color, it changed the taste, it changed the texture, and there's probably more if we want to talk about more. But that's 3. That's pretty good. So then we need to go to this bottom part. Which of these models happens? Which of these models matches this change? Okay, so model A shows that 1 black, 4 white is a carbon, 4 oxygen, or 4 hydrogen, 2 oxygen. They changed into these things. To me, that doesn't make a lot of sense because you're missing an oxygen. You guys notice that? There's 2 over here, 1 over here. It's not balanced. Can't be it. That can't be what's happening. Over here, this is the same. So we have 2 of these now. But these are the same. This is like it didn't change. This would be a physical change because it didn't change at all. Look, these reactants are the same as these products. Over here, though, you're getting some rearranging, and it's a balanced equation. 1 black, 4 red, 4 white. Yep. So I'm going to say that this model makes the most sense. I'm just going to maybe like highlight the C, or I can maybe put like a green box around it. There I go. So my evidence supports my claim because what happens during a chemical reaction? These are kind of 2 sentence starters to help you think of the same thing. Because if the because when you burn a marshmallow, the properties change. This is because during a chemical change, the atoms separate and form new molecules in the products. So what I just did, and I can just take the sentence out, maybe that doesn't help. What I just did was I wrote an ACE. I wrote an A-C-E. In language arts class, you write races. You respond with an answer to a question, but I just wrote answer with a claim. So we actually answer with a claim, then we cite evidence and explain your evidence. We just write an ACE. Okay, so what you're going to do is you're going to do the same thing for independent work 3 times. You're going to watch this video and talk about it. You're going to watch this video and talk about it. You're going to choose which model for both. And then finally, you're going to do one for the exit ticket. This one, I put back your explain part. I want you to practice that part. Watch this video, choose the model that matches, etc. That's it.